Hello everyone. Right now I'll be presenting my project CineGuru, which is a movie recommender system. So these are the table of contents. I'll start with about my app, then the three types of movie recommenders in my app, and a short code demonstration, and then I'll proceed to the acknowledgements. So about me, my name is Tanush Shenai. I'm in grade 9 and I'm 13 years old. AI interests me because of its prospects, innovative and new technologies, and its versatile applications in many domains like hospitality, defense sector, entertainment, etc. I feel AI, along with Python, will be very beneficial to the society. Through the internship, I was able to learn Python and AI concepts and apply them to make a socially useful project, a movie recommender system. About my app, CineGuru is a movie recommender system. Its main function is that the user will input his or her user ID and the title of a movie, and then content-wise related movies sorted on the basis of previous ratings of other movies by the user will be recommended. It will give a content-based recommendation based on the description of the movie entered, which means that movies with similar cast, crew, description, etc. will be recommended to the user. Additionally, it will also give a collaborative based recommendation according to the previous ratings of other movies by the user. It will also feature a simple recommender where the user can specifically enter their preferred genre or just type top movies, which will give return either top movies in the specific genre or just generally top movies according to IMDB Weighted Rating System. A unique feature of the app that is it will also recommend movies by analyzing the mood entered. I chose this project as it is socially beneficial and will help users to choose a movie fast and correctly for any occasion. It will also suggest movies based on the mood or genre, thus uplifting people by inspirational and peppy movies when they're feeling low, or suggesting fast-paced movies with fighting scenes for those who love the action genre. It will improve the quality of entertainment and help people to truly enjoy what they watch. So the first option is the hybrid recommender system. Here the user must enter their user ID and the title of a movie for which they want similar recommendations. Then a chart showing the top end that will be entered by the user. Similar movies will be displayed based on the previous ratings of other movies by the user, and the content wise and overview wise a match of the similar movies to the one entered. And these will be sorted in descending order on the basis of their IMDb weighted rating. So the first option is the hybrid recommender system. Here the user must enter their user ID and the title of the movie for which they want similar recommendations. Then a chart showing the top 10 similar movies will be displayed based on the previous ratings of other movies by that user, and a content-wise match and overview-based match of the similar movies to the one entered, and the movies will be sorted on the basis of their content-based and collaborative-based similarity scores. So the approach that I've used for the hybrid recommender system, first is that I've used term frequency, inverse document frequency, and cosine similarity. After cleaning and pre-processing the data to take only part of the data frame, the code creates a TF-IDF matrix for movie overviews. This matrix represents the importance of words and sentences in the movie overviews. Then cosine similarity creates a linear kernel between the TF-IDF matrices of movie descriptions, and this quantifies how similar one movie's description is to the others. Then resetting indices and defining the titles and indices. The code resets the index of the descriptions and defines two important things. that is movie titles and indices of movies in the data frame. The recommendation function, get recommendations, takes a movie title as input and returns a chart of recommended movie titles based on content. Sorry, returns a list of recommended movie titles based on content similarity. It finds the index of the input movie title and calculates the cosine similarity scores between that movie and all other movies. The function then sorts the movies by similarity score and returns the top 30 similar movies, excluding the one entered. Then there is the collaborative filtering. So first, there's the matrix factorization. The user item ratings data is loaded into a data frame. The user item matrix is created where rows represent user ID, columns represent movie ID, and cells represent the user ratings. Missing values are filled with 0. Matrix factorization uses truncated singular value decomposition, and that is performed on the matrix to reduce its dimensionality. Then cosine similarity is performed on this reduced matrix. Then the collaborative filtered recommendations function. This takes a user ID as input and returns movie recommendations for that user based on the collaborative filtering. It calculates the cosine similarity between users' ratings and all other users' ratings using the reduced SVD matrices. Unrated movies which the user hasn't yet seen or rated are identified, and scores are calculated for these unrated movies. The top recommendations are determined based on these scores, and this ensures that there isn't any repetition of similar movies that the user has already watched, and the user gets a new movie that is similar to the one entered. The hybrid recommendations function. It combines the content-based and collaborative-based recommendations. It takes a user ID and movie title as input, and content-based recommendations are generated for input movie using cosine similarity scores. And collaborative-based recommendations are predicted for the user. Recommendations are combined by adding the similarity scores from both the methods, and top 10 hybrid recommended movies are returned based on the combined scores. The simple recommender system. The user must first select in a combo box the genres, or they have an option of top movies. For top movies, the user will be asked to enter how many top movies they want to see, and a chart of top N movies based on IMDB weighted rating will be shown. For genres, a list of unique genres in the whole data will show as a combo box, from which user will select one and the top N movies of that genre will show. So the approach I've used for the simple movie recommender. First, I've done the data pre-processing and calculating the constants C and M. So here vote counts and vote averages are created by selecting non-null values from the vote count and vote average columns of a data frame that contains movie data. The constant C is calculated as mean average of vote average values, and for M I've taken the threshold as 95%, which will be the minimum number of votes required of the vote counts values. So the year extraction, a new column year is created in the data frame by extracting the release year from the release date column in the already existing in the data frame by using the pd.to underscore date time function and a lambda function. This allows one of the columns of the qualified data frame to be a year. So the qualified data frame where I've filtered the qualifying movies. A data frame named qualified is created by filtering movies based on the criteria that number of votes, that is vote count, must be greater than or equal to M. Vote count and vote average must not be null. This data frame includes columns title, year, vote count, vote average, popularity, and genres. And both vote count and vote average are converted to integers. So as you can see on the slide, this is the weighted rating formula that even IMDb uses. After that, I've sorted the movies by weighted rating, and the qualified data frame is sorted in descending order based on the weighted rating column, and this effectively sorts the movies. Last, the genre chart building, which is the build chart function. I've defined this function to build movie charts for a specific genre. It takes a genre as an input and an optional like percentile parameter. The default I've put as 0.85. The function filters movies of the specific genre from gen_md data frame, a data frame that combines movie data with genres. And then the process of calculating C, M, and creating the qualified data frame for this genre is similar to what I did earlier. Weighted ratings are calculated using the weighted rating function. And finally, the function returns the top 250 movies of that genre, sorted by weighted rating in descending order, out of which top n movies will be displayed, where n is the number that the user enters. So the mood-based recommender, that is the third option. Here, the user must enter how they're feeling in a text box and submit it. And then a lexicon-based sentiment analysis will be conducted on the text, from which a sentiment polarity score will be generated. If the score is greater than zero point 0.2, the mood is considered happy. If score is less than zero point 0.2, minus zero point 0.2, mood is considered sad, and else the mood is considered neutral. Based on the mood, the user will be asked to select a genre from a genres list tailored to that mood. Then a chart of top n movies, where n is the number that will be entered by the user, in that genre will be showing in descending order of the IMDb weighted rating. So the approach that I've used for the mood-based movie recommender system, the approach is pretty much the same as the simple movie recommender. The only difference is that I've used the genre lists, lexicon-based sentiment analysis. Yeah. For genre list, first a list of unique genres in the whole data frame is created. Then three lists, happy, sad, and neutral, each store specially tailored or like a specific genres to that mood. The lexicon-based sentiment analysis using the text blob library, the user enters his feeling in words or sentences. Then the sentiment analysis is conducted on it using the text blob function. If the input text sentiment polarity is greater than zero point 0.2, as I said, the genres available to the user will be of happy mood. Else, if the sentiment polarity score is between zero point 0.2 and minus zero point 0.2, it will be neutral. And if it's less than minus zero point 0.2, the genres will be.
So now first I'll be showing the output of my hybrid movie recommender system. So if I'll just run the code, as you can see, there will be a brief about what the hybrid movie recommender does. Then there are two empty text boxes where the user has to enter his ID and the title of a movie that he or she wants a similar recommendations for. And then there's the submit button to send the values, and results will show the chart. So I'll just type, I put user ID as 1 and title as avatar. Then if I submit results, so as I said, top 10 movies that are recommended on the basis of hybrid are recommended to me, and these are similar to avatar. So, and the columns here are title, vote count, vote average, popularity, and yeah. So this was the hybrid movie recommender. Now I'll be running the simple movie recommender, that is the genres and top movies. So again, this will be a small brief about what the simple movie recommender does. Here, this is a combo box where the user can select the preferred genre, or just they can choose top movies. Here, this is a text box where the user must enter how many top movies they want to see, and they can submit this and then click results to see the output. Or if they want to, once they select something and they want to change their option, they can click clear selection and select it again. So first I'll test the top movies output, and I'll put top six movies and results. So as I said, top six movies in the whole data set are showing, and yeah, these are the top six movies. Now I'll be running the genres. So say I put history and I put four. So top four history movies are showing. That is, and these are recommended on the basis of the genre and IMDb weighted rating, as you can see here. And as I said, these ratings are the output is sorted on the basis of in the descending order of weighted rating, as you can see here. So this was the output of my simple movie recommender. Now I'll be running the mood-based movie recommender system. Okay, so here one must enter how they're feeling. So as I said, this is the text on which the lexicon-based sentiment analysis will be conducted, and based on the sentiment score, a genre list will be appearing here. So currently this is blank because I've not entered any mood. If I say I am feeling um good, and if I say I want to say see top three movies, submit. So it correctly detects the mood as happy. And now this is the genres list which I get, which are available for happy movies. So here I select say fantasy, and select results. So top three fantasy movies are recommended to me. And again, as I said, they are sorted on the in descending order of their weighted rating. Now, if I run the code again, and if I type this time, say I'm feeling, and I put top five movies, submit. So it correctly detects the mood as sad. And this mood-based recommender is particularly useful for helping the user receive genres and movies that are tailored to their specific mood. Like for example, in this sad mood scenario, there's another list of genres from which the user may choose. So thus, it may also help them to get out of that and feel happy once again. So here, as I said, there are more genres available, such as music. And if I click result now, yeah, so top five music movies are showing and sorted on the basis of their weighted rating. Yes. So this is the mood-based movie recommender system. So I hope you liked my project and the code, and thank you.
So this is my app development toolkit. First, I'll specify the project requirements. Um, for the hybrid recommender, there were four elements required actually. Input text box, another input text box, and the submit and result buttons, all of which I've successfully completed. For the simple movie recommender, I needed an input drop-down, input text box, a clear selection button, and submit and result buttons, all of which I've successfully completed. And for mood-based recommender, I needed two input text box, a clear selection, and the submit and result buttons, which I've again completed. So next I'll move to the design user interface. Here I'll be showing three screens, and this is how the app looks like. The first is the hybrid movie recommender. As you can see, the two text boxes, the submit and result buttons. That is for the hybrid movie recommender. Then for the mood-based movie recommender system, you can see the two text boxes, a combo box, and the output and the submit and result buttons, and the clear selection button. Then for the simple movie recommender, as you can see, there's the drop down of the genre, or you can type, or you can enter top movies, and one text box for number of movies to be shown. And then there's the submit results and clear selection buttons. So this was my design user interface. Then let's proceed to the event handler matrix. Here again, it's divided into the main or hybrid movie recommender, simple recommender, and mood-based recommender. For the hybrid, as I said, there are three elements and actions. So first, the first input text box takes the input of user's ID, which will be used for executing the main recommender. Then the second input text box is again used to take input of the movie title, and it uses these values for executing the main recommender, that is hybrid recommender. Then the submit and results button on clicking submit, the action or the values will be sent, and on result, the chart or the output will be showing. So then let's proceed to the simple movie recommender system. Here again, there are four elements. As I said, input drop down, input text box, clear selection, and submit and result buttons. So for the input drop down, it takes input of any preferred genre of the user, or just one can enter top movies. And it uses this value for executing the simple movie recommender. Then in the input text box, takes input of how many top similar movies the user wants to see, including like the maximum they can see. And what happens here is that it uses these values to determine how many top similar movies or recommended movies are to be shown. Then there's this clear selection button, which on clicking clears the combo box selection. That is, it clears the selection that the user has done for the drop down. The submit and result button on clicking execute the simple, that is genre based or top movies recommender, or shows, as I said, top movies based on IMDB's weighted rating. Last is the mood based movie recommender system. Here again, there are four elements: input text box, another input text box, clear selection, and submit and result buttons. The input text box uses the text for sentiment analysis, and it uses these values for executing the mood-based recommender and actually particularly determining the mood. Then the other input text box takes input of how many similar movies the user wants to see, and it uses these values to determine how many top similar or recommended movies should be shown. Then there's the clear selection button, which on clicking clears the combo box selection. That is for the genres, that is. And the submit and result button on clicking executes the mood-based recommender. So then we'll proceed to the test plan. So as I explained, everything here is same from the event handler, the elements, the action, and what happens. So I've tested all the elements of uh, all the three movie recommenders, and luckily all of them have passed. So yeah, this was my app development toolkit, and I hope you liked it. Thank you. Before I end, I would like to thank all those who have helped me in this journey of project and app development: my parents, my mentors, Mr. Abhishek, Miss Meeta, Miss Shivani, Mr. Kane, and websites. Thank you.